What's poppin', dogs? Mr. Allen here with some solving of logarithmic equations in this video. And we're going to be doing problems that require properties and ones that don't require properties, so be ready for anything here. And of course, got to check for those extraneous solutions, meaning a solution that you got correctly through algebraic steps, but doesn't work in the original problem. So let's get after it on the first one. I've got log base 6 of x squared plus 5x equals 1. So the argument of this logarithm is quadratic. Interesting. So how do I go about solving this? Well, if I have a log on both sides of the equation, I can just cancel them out, the one-to-one property of logarithms, and go from there. But here I only have a log on one side. How do I deal with that? Well, I'm going to rewrite it in exponential form. And the way that I do that is with a little thing called a loop and a swoop, okay? We're going to start with the 6. That is my base. Raised to the first power equals my argument of that logarithm. As you see there, the order in which I looped and I swooped. I started here, pass by the 1 next, that's in the second spot, land on the argument of the log, that's what it all equals. Dope. 6 to the first power is just 6, and this is a quadratic, so I'm going to set it equal to 0, factor, and solve, and let's go from there. So we got 0 equals x squared plus 5x minus 6. Okay, people screw this one up all the time when they're factoring because these numbers are only 1 apart, meaning I can multiply to 5 and I can add negative 6, and I can multiply to negative 6 and add to 5. Keep in mind, we always multiply to the constant, and I add to the coefficient of that linear term. That's why a lot of them refer to it as AM method. Add to this, multiply to that. Cool? Dope. So what multiplies to negative 6 while adding to 5? Well, that would be, let's see here. 6, negative 1, yes. X plus 6, x minus 1. That multiplies to negative 6, yay. 6 minus 1 is 5, yay. Now I'm going to set these two equal to 0 and solve. But keep in mind, I'm going to get negative 6, I'm going to get positive 1. Do they both work in the original problem? If I plug negative 6 in, I get 36 minus 30. That's 6. Log base 6 of 6 is 1. Hey, that works. A lot of times our negative, we're like, whoa, no, can't be negative because you can't have a negative in the argument of the log, meaning this whole expression here cannot be negative. But when it's squared, and then I subtract the 30, we're all good. Plug in a 1. 1 squared is 1, plus 5 times 1, which is 5. 1 plus 5 is 6. Log base 6 of 6 is 1. Keep that in mind here, guys. Log base 6 of 6 equals 1. That's saying 6 to what power equals 6. That's how you evaluate a logarithm in your brain, okay? 6 to what power gives me 6? It's 1. Cool? So both of these actually work here. No extraneous solutions exist on this first example. How wonderful is that? Will we be so lucky in the next one? I don't know. I do know. Pretty sure there's an extraneous. But let's find out, right? You got to watch to find out, dogs. What do I do here? I got 2 logs. Could I subtract this over and use one-to-one property of logs? Well, no, because I have a 3 there. So that doesn't do anything. What if I were to condense this into a single logarithm? Meaning log base 2 of... And then I'd have x times x minus 7. I take the product of those two arguments, and that equals 3. Ooh, okay. Okay. So with addition, it condenses to multiplication. Subtraction, which we're going to see here in a moment, condenses to division. All right. So let's distribute that x, and I got log base 2 of x squared minus 7x. Well, this is certainly looking a lot like this last problem now. And that's a common strategy in math, is we try to transform a new problem, where we're like, what? How do we do this? To something that looks like an old problem, like this. And then we transformed it into something that we definitely know how to do, a quadratic, which I can factor and solve. Yay! See how we just bring it back to like previous math once you know the new math. All right. So now I'm going to loop and swoop this bad boy. 2 to the third power equals x squared minus 7x. We start with the base, raise it to the third, equals the argument, America. So we got 8 right here equals x squared minus 7x. So we'll set that equal to 0 equals x squared minus 7x minus 8. Now what multiplies to negative 8 adds to negative 7. As you can see here, guys, you kind of need to know how to factor still. After your quadratics unit and your polynomials unit, you're still going to have to factor. We always bring factoring back in math because factoring is dope. Factoring is my favorite F word, okay? If you're wondering about my second, it's fraction. If you're wondering about my third, function. All right, 4th factorial. Moving on. Can't say my 5th. So what multiplies to negative 8 adds to negative 7? That'd be negative 8, positive 1. That multiplies to negative 8 while adding to negative 7. We often forget about the number itself and 1 as being one of our potential factors that will work. And I see people stare at this one all the time and like, what? There's nothing. It's just 4 and 2 that multiplies to 8, and that doesn't add to negative 7. What about 8 and 1? Boom. So now I have x equals 8 and x equals negative 1. Remember, I'm setting these factors equal to 0 and I'm solving. I'm just skipping that step because I don't have a ton of real estate here. Do they both work? Well, when I plug in 8, I get log base 2 of 8 and I get log base 2 of 1. Okay? Positive numbers in the argument are the main thing that I'm looking for a quick check. So I'm going to say that this one works. All right, but if I plug in negative 1, it does not work here with this x, right? Because I'd be doing log base 2 of a negative number. No bueno. So this is extraneous, meaning it's a solution that you got through correct algebraic steps, but doesn't work in the original context of the problem. So no bueno, right? 8's the only correct solution. And if we were to actually evaluate that one, I'll do that in a different color up top. Log base 2 of 8 plus log base 2 of 8 minus 7 is 1. Well, 2 to what power gives me 8? The third. And 2 to what power gives me 1? Well, the only way to get 1 is by raising it to the 0 power. So 3 plus 0, that certainly does equal 3. You can plug that into your calculator if you'd like. These are all definitely no calc problems. If a test is to be split into calc versus non-calc, all three of these, no calculadora, okay? All right, now for this last one here. We've got 3 different logs going on here, and wait, hold on. There is no base, right? No, there's no little number written here. What the heck does that mean? Well, that means it is the common logarithm, which is base 10. So anytime you see just log written there, it is implied that it's log base 10, right? And now, that one's not really going to come into play here in this particular problem, but if it was like that with one of these, big deal, guys. You need to know what that base is. All right, so if you don't see the base, it's base 10. Dope. Now what do we do? Well, I got 2 logs on one side, 1 log on the other side. If I got down to 1 log on the left side, I could use the one-to-one property of logarithms, drop the logs, set the arguments equal. Boom, moving on. Let's do that. Subtraction condenses to what again? Division. So I can write this as 1 log base 10. I don't even have to write base 10. Of, now it's x squared plus 14 over x plus 1, close it, equals log of x plus 4. Boom. Now I have log and log on both sides, log base 10 on both sides. One-to-one property of logarithm says the arguments are equal. And that makes sense, right? If I have the same thing here, those got to be the same inside that thing, right? So let's drop those logs and let's set the arguments equal to each other. So I'll have x squared plus 14 over x plus 1 equals, check this out, x plus 4. How do I solve that? Got an idea now? Got 2 fractions, crisscross, cross multiply. That is street math, but I don't care because I like to call it cross multiply. So anyways, multiply those two, and let's solve it. I'm going to do it in a different color now that we're in a different stage of this problem, essentially. So we have x squared plus 14 times 1. That's just x squared plus 14. And this might look kind of intimidating because we got the quadratic going on, all that stuff. It's going to be okay. It's going to be pretty dope. And I got x plus 1 times x plus 4. Let's multiply, distribute, FOIL, another street term, this right-hand side, meaning it's going to be x times x and x times 4, and then we'll do the same with the 1. So I got x squared plus 14, left side doesn't change, and then I got x squared plus 4x, 1x, and 4, so plus 1x plus quattro, and now let's clean things up. The x squareds. If I subtract x squared from both sides, what's going to happen with these guys? Gone. So now I'm just left with all wonderful easy math, okay? I got 14 equals 4x plus 1x is 5x plus 4. Oh my goodness. Look how beautiful this is going to end up. 10 equals 5x. So x equals 2. Before I circle it, settle down. We're going to do a quick check, okay? I got 2 here. 2 squared is 4 plus 14. It's 18. We're good. 2 plus 1 is 3. We're good. 2 plus 4 is 6. We're good. Now, I can't evaluate that by hand. I could probably throw it in here in the next one and kind of do some stuff. But again, the main thing I'm looking for when it comes to extraneous solutions is my argument of the log, what's inside the log, is that positive? And yes, this checks out, okay? It would be kind of a mean move to give you an extraneous solution when it was a result of it would be a whole thing. Anywho, I'm looking for positives inside my logarithms. This one's good to go. X equals 2 is perfect. And keep in mind here, guys, that it's all about the original, okay? It's the original problem you're testing. When I plug 2 into the original, are we good? When I plugged 8 into the original, were we good? When I plugged -1, no, we weren't good. But if this were the original, right, this line here, kind of like we had here, -1 squared is 1, plus 7 is 8. This would have worked then. If this was the original problem, both solutions work. Because the original problem was expanded like that, we get an extraneous solution. All right, so be on the lookout for that. Check for negatives inside the log, which is our argument. Argument's got to be positive. Always stay positive during an argument. Otherwise, you're just going to lose yourself, okay? That's enough. You guys have a great day. Thanks for watching. If you have any questions, pop in the comments and have a dope day.